W vector is equal to half of curl of V vector and V vector is equal to curl of U vector. Then we have to show that this volume integral is equal to sum of the surface integral and twice of this volume integral. Now these are two volume integrals, right? And this alone is a surface integral. So we need to apply the Gauss's divergence theorem over the surface integral. Before starting with the proof, let's read this remark, which is very important and used in many examples, right? So what the remark is, divergence of cross product of two vectors is equal to second vector, its dot product with curl of first vector, minus, then we write the first vector, its dot product with curl of second vector. In the previous contents, I have already explained this proof how we are getting the right hand side. And now again I am proving this result. Please remember the steps. You have to use those steps in the examples, right? Because I will be using direct result in the examples, right? Okay, let me explain the proof. So this is equal to the summation I vector its dot product with partial derivative of this vector with respect to x. Let's partially derivate this cross product of two vectors. So writing here first vector, its cross product with partial derivative of v vector with respect to x plus partial derivative of u vector with respect to x and its cross product with v vector. Very fine. And now separating the summation. Now we know that the cross product of two vectors is equal to negative of cross product of these two vectors. Yes, so I'm going to use this result in this step. And now for the second term, I'm going to use a result. How we are going to use that result? Just shift this dot to this cross and shift this cross to this dot. So how we write? Plus summation I vector its cross product with partial derivative of u with respect to x, taking this in bracket, dot product with v vector. Similarly, we have to do this for this term also in the next step, shifting this dot to this cross and shifting this cross to this dot. Why I have done this? So that I can get the curl of u vector and curl of v vector. So this is nothing but curl of u vector and this is nothing but curl of v vector. So let's replace this with these. Because we know that dot product of two vectors is equal to dot product of b vector dot a vector. We can interchange them, right? So let's interchange this. So this is negative of u vector, its dot product with curl of v vector. Plus here also let's interchange this. This is v vector dot product with curl of u vector, right? So we have reached this result. You can write the second term in place of the first term and first term in place of the second term. So you have to remember these steps and write these steps in the examination. Now let's start with the proof. What we have to do is, we have to apply the Gauss's divergence theorem on this surface integral, right? So from here we have to start. So let V be the region enclosed by the surface S. Then by Gauss's divergence theorem, this surface integral is equal to, because we are having dot product of these two, so this is volume integral of divergence of this vector. Now we know that divergence of u vector cross product with v vector is equal to, yes, second vector is dot product with curl of first vector minus first vector its dot product with curl of second vector. Let's use this result over here. So we get this surface integral further to be equal to the volume integral of, okay, writing here v vector dot product with curl of u vector minus u vector dot product with curl of v vector dv. Now what are u vector and v vector given to us? V vector is curl of u vector and curl of v vector is twice of w vector. Yes? See, curl of u vector is equal to v vector. and curl of v vector is equal to twice of w vector. So writing here curl of v vector to be as twice of w vector, and writing here curl of u vector to be as v vector. So let's write this. This is equal to the volume integral of dot product of v vector with itself minus u vector dot product with curl of v vector. So dot product with curl of v vector is twice of w vector dv, right? Okay. So this is further equal to the volume integral of v vector dot product with v vector dv minus twice of volume integral of u vector dot product with w vector dv. And dot product of v vector with v vector is v vector square. Now on the left hand side, we are having this surface integral, that is the surface integral of cross product of u vector with v vector dot n vector ds, right? And this is equal to this right hand side. But we have to show that we need to take on the left hand side the volume integral, right? And we have already got this result and this result also. Now let this integral to be remain here, taking this to the other side. Hence we have proved this result. Okay, thank you.